Now, allow us to discuss the transportation engineering simulation software. In many cities and towns today around the globe, road traffic infrastructure is being utilized to its full capacity. The optimization of crossings and traffic networks can thus be predicted to grow in importance in the future. With the ongoing advancement of computer technology and software, traffic simulation models have grown increasingly practical and popular. The aim of computer simulation is to transform ideas into tangible business solutions. This include increased revenue and increased profit, especially that reduce cost. It can smoothly guide through digital transformation, keeping agile that enables to mimic life traffic situation in a particular location. Through simulation, transportation specialists can study the formation and dissipation of congestion roadways, assess the impacts of control strategies, and compare alternative geometric configuration. It tests different ideas under certain circumstances to get valuable information to base important decisions about the mobility ecosystem. No matter how complex your vision is, it will bring alive with proven digital engineering solution. Simulation models have different characteristics. Each simulation model has its own logic and use limitation and is applicable to specific components of transportation system. For the sake of this discussion, we are only about to focus on the microscopic, macroscopic, and mesoscopic that are going to be discussed later on. Now let's move on to the classification. A variety of traffic simulation models have been developed since the 1960s. The simplest model may be based on the classification of facilities that the model can analyze. These include the urban street networks, freeway and freeway corridor, and the mixed network. Starting off from urban street network. Urban street traffic systems comprise intersection, grade-based networks, and a variety of complex traffic activities and control strategies such as parking adjacent to traffic stream, bus blockage, one-way streets, reversible lane operation, and so forth. This system excludes freeways, expressways, and all types of limited access facilities. As you can see in the pictures, these are what an urban street networks look like. It is a 1 square mile street networks of well-known cities like New York, Paris, Rome, Dubai, and so on. Comparing it here in the Philippines, oftentimes we experience congestion along Metro Manila and its nearby cities, which up until now, our urban street network still needs an improvement from railways to roadways. In year 2017, a group of researchers from the University of the Philippines, Diliman, conducted a review that compared different traffic simulation software and choose which is the most viable for the researchers to stimulate the EDSA traffic. Somo, Vissim, and Awesome were found to perform reasonably well and had common and unique features with different strengths and weaknesses. Traffic models describe the details of traffic flow and the interaction taking place within it. Microscopic traffic models simulate single vehicle driver units. The dynamic variables of the models represent microscopic property like the position and velocity of single vehicle, and it plays in two categories, which are the cell automata model, which are discrete in time and space, and then the continuous model, which are discrete in time, and it require detailed studies of car following behavior and traffic instabilities. The same traffic. It is a complement to Synchro as it models individual cars, trucks, buses, and pedestrians traveling through a network of freeways, streets, and multiple types of intersection. So this uses 2D and 3D animations of transportation model, and the simulations are effective tools in conveying the operation of complex transportation facilities in public presence. see in the image display, this is a 3D view of a junction simulated in a sim traffic application. Next is the TraffNet Sim. The TraffNet Sim model uses an interval scanning simulation approach to move vehicles each second according to car following logic and in response to traffic control and other conditions. It uses Monte Carlo procedures to represent real world behavior.
So good day everyone. Today I'll be reporting about the urban street networks in the macroscopic level. So the macroscopic model traffic is used for assessing and formulating traffic flow. So this macroscopic level is important to produce a blueprint for safe routes. So there's a difference between the simple and high continuum model. So in simple continuum model, there is a no acceleration and inertia effects that describes a non-equilibrium traffic flow. On the other hand, the high continuum model, there is a acceleration and inertia effects that uses a momentum equation. So there are different types of software under the macroscopic. So one is the EVIPAS, or which is called the Enhanced Value Iteration Process Activated Signals. So the EVIPAS is a program design that utilize and optimize a wide range intersection, pacing, and controller characteristic of an isolated, fully activated traffic signals. So based on my research, it has been a field tested and validated and replicates a well observed vehicle in a signal behavior. So this EVIPAS software looks like. So number two is the net flow or the network traffic flow simulation. So the net flow is a used to assess a communications network efficiency. So there are two levels. One is the net flow one, and two is the net flow two. So one is the net flow one, or which is called the stochastic. So it is determined event based model, but there is a random threats each vehicle within the network as identifiable. So on the other hand, the NetFlu2, or which is called the deterministic, um, this is the deterministic is interval based model that determines a movement in movement traffic flow and specific statistical histogram. So the NetFlow software looks like. So number two is the passer, or which is called the progression analysis and the signal system evaluation routine. So the passer, it is a unique general purpose computer program that develops a develops to assist a traffic engineer in determining the optimal traffic signals timing for an arterial street where the progression is desired to the signals having more than one arterial signal pace. So the passer software looks like, um, and the synchro software is the traffic signal timing software that supports a engineers and transportation planners to design, model, optimize, and simulate and animates the signalized and unsignalized crossings. So the Synchro software is also the well known as the applications that allow engineers to analyze the signal timing in hours versus the days, and the new release continues to include key recommendations from the customers. So the Synchro software looks like just like the Passers software. So the Synchro software uses a formula that it has a cycle length optimization base. So the given formula is performance index is equals to the d percentile delay plus the 10s plus the 20q plus the 300u all over the 3 3600. So also the Synchro software uses another formula which is called the coordinability factor that it it is generated by the synchro software to assess a signal in a network should be coordinated. So the coordinability factor is equals to the max CF1 CF2 plus the AP plus AV plus AC. So lastly, the transit software, or which is called the traffic network study tools. So the transit, there's an individual vehicles are not represented in transit. So and all computation are based on the average flows and the turning movements and also the queuing. So the transit uses a formula that to perform a plane simulation, which results in the performance of the existing network without any alterations. So the formula, which is called um, this utility index, that it is attempts to minimize by manipulating signal settings. So DI is equals to the summation of all WDI times DI plus the KW sub SI times the SI plus UI times the WDI minus 1 times the DI minus 1 plus the KWSI minus 1 times the SI minus 1 and the plus QP. So that's all. This reference taken in transportation engineering and planning. That's all. Thank you.
So moving on to the mesoscopic model. For this model, I included two traffic simulation softwares, and those are the Contram and Saturn that I will be discussing later. Okay, so mesoscopic combine the properties of both macroscopic and microscopic simulation models. This photo depicts how the three models are different to each other. So, mesoscopic models may include a routable network similar to the macroscopic model, while also incorporating more detailed operational elements of the transportation network to better estimate travel time based on traffic operation, similar to microscopic model. So basically, mesoscopic model is a hybrid model that includes the combinations or approximations of elements from both macroscopic and microscopic models. Okay, so the first software is the CONTRAM or the Continuous Traffic Assignment Model. It is a traffic assignment and simulation model that treats a group of vehicles as a single entity, thus vehicles that belong to a packet travel along the same minimum cost route and arrive at the same time. Contram determines time varying link flows and route costs in terms of given time varying route inflows in a dynamic setting. As such, it is entirely different from transit and netsim. In Contram, traffic demands are expressed as OD or the origin destination rates for each given time interval. These OD rates are converted into an equivalent number of packets which are assigned to the network at a uniform rate for each time interval. A traffic assignment equilibrium is achieved through iterations in which each packet is removed from the network and reassigned to a new minimum path. So, in layman's term, it is a computer model of time varying traffic in roads networks in which with the use of this software, you will know your travel time and travel cost from your origin and destination zones. Okay, so this is what Contram software looks like. This software is being used by some navigation apps such as Google Maps, Waze, and etc. Okay, so the next software is the Saturn, or also known as the Simulation and Assignment of Traffic in Urban Road Networks. It is a traffic assignment model based on the incorporation of two phases. A detailed simulation phase of intersection delays coupled with an assignment phase that determines the routes taken by OD trips. The complete model is based on an iterative loop between the assignment and simulation phases. Thus, the simulation determines flow delay curves based on a given set of turning movements and feeds them to the assignment. The assignment uses these curves to determine route choice and updated turning movements. These iterations continue until turning movements reach reasonably stable values. So basically, this traffic assignment software is being used to determine the traffic delays and also find another routes that will make the transportation travel time of a driver more efficient and faster. Okay, so this is what the Saturn software looks like. And same with the previous one, which is the Contram, it is also being used by some navigation apps company to determine the route choices. Okay, so now we are now moving on to the second classification, which is the freeways and freeway corridors. Freeways and freeway corridors. A corridor is a roadway system consisting of a few primary longitudinal roadways carrying a major traffic movement with interconnecting roads that offers the drivers alternative paths to their destinations. Freeway models usually simulate traffic flow on the integrated system of a mainline freeway and its ramps, whereas freeway corridors models can simulate the traffic on a mainline freeway and its ramps as well as on neighboring arterials. So the only difference of this classification to the previous one, which is the urban road network, is that freeways is a limited access facility and is not part of the urban street network. So some example of freeways here in the Philippines are NLEX, SLEX, TPLEX, Star Tollway, and other expressways.
For the monitoring and control of freeway and freeway corridors, there are two broad categories, namely the microscopic and the macroscopic. And I will be discussing about the microscopic. So these are the examples of microscopic softwares. These are Intras, FreSim, CarSim, WeaveSim, and FreeSim. So let's start with Intras. Intras, or integrated traffic simulation, was one of the most well-known freeway simulation models that is used for simulation experiment. It is a stochastic model developed by KDL Associates in the late 1970s and was enhanced continuously through 1980s. It uses vehicle-specific, time-stepping, detailed lane changing, and car-following logic to represent traffic flow and control of a freeway corridor according to the surrounding surface street network if desired. So what does lane changing means? Lane changing refers to the lateral traffic behavior of vehicles, while car following refers to the longitudinal behavior or movement of vehicles. So this is what Intras looks like. These are the statistical analysis framework of Intras. Next is FreSim. FreSim, or Freeway Microsimulator, is an improved version of Intras. Intras was improved in order to enhance according to the structural design techniques and also to make the software more user-friendly. It can simulate complex freeway geometries, inclusion of auxiliary lanes, and variation in slopes, super elevations, and radius curvature. It can handle freeway operational features such as lane changing and one-ramp metering. This is what FreSim looks like. Next is the CarSim. CarSim was also based in Intras, and what was I have mentioned earlier, Intras is very much general. Compared sa CarSim ay dinevelop kasi mas detailed siya and mas focused siya sa pag-analyze ng car following condition sa isang freeway. It is more specific compared to Intras. CarSim was developed to offer additional realistic features which Intras cannot do and capabilities for simulation of car following behavior on freeways. This is CarSim GUI and visualizer, and these are the features of advanced features are CarSim and 3D multiple vehicle interaction. Next is WeaveSim. WeaveSim, same sa CarSim, is based on Intras, improved version of Intras. Since Intras is general, may mga specific na task na hindi niya kayang magawa gaya ng intensive lane changing maneuvers. that is why na-develop yung WaveSim, since ang WaveSim ay focused siya sa pag-develop specifically for the study of dynamics of traffic flow in weaving sections. Next, lastly, the FreeSim. FreeSim is a stochastic model whose logic is based on a rational description on the behavior of the driver in a freeway lane closure situation. This is more focused on the behavior of the drivers and the effects of the signages to the drivers. A set of algorithms were established to simulate driver car following and lane changing behavior in response to MUTCD warning signs. This software can be used in order to evaluate yung effect ng paglalagay ng mga signages, yung may mga non-conformity ba sa mga standards, mga poor maintenance, can also be used para ma-evaluate yung impact or the effectiveness of random signs na nilalagay sa freeway lane. Syempre, pinag-aaralan muna yung mga signs bago i-apply. At once na nalagay na siya sa freeway or nalagay na siya dun sa location, ito yung software na ginagamit sa ma-assess yung effectivity ng mga MUTCD signages.
I will now discuss the second category of freeway and freeway corridors, which is macroscopic. So, under macroscopic, there are 4 models present. These are Cork, FREC, Free Flow, and Chronos. The first one is Cork or corridor queuing. It is a freeway corridor network assignment and simulation model developed by Agar in the early 1970s. Its main key element is to distribute the entire origin destination demand to each subnetwork. And then the travel time between origin and destination are dependent to link flows and intersections delay. So sa Cork, tinitignan nito yung mga pinanggagalingan at destinasyon ng mga dumadaang sasakyan at kung gaano sila karami. And after having those data, ikakalculate naman ito yung supposed time travel kasama yung mga delay sa intersections para marating nila yung pinaka-destination. So, in the 1980s, due to it is the most detailed corridor level, Cork is incorporated in integration model. So, sa lahat ng macroscopic model, yung Cork yung pinaka-detalyado sa lahat. So, dahil dito, para mabuo yung isa sa mga integrated simulation model, which is integration, ginamit siyang inspiration. So, yung integration will be discussed later on under mixed network. So, under Cork, if there are ever traffic flows na hindi nakarating within the given time period dahil sa overloaded capacity ng freeway, it will be carried over and be considered for reassignment. Next is FREC. FREC is a freeway model that is developed at the University of California since 1968. The FREC family has been under continuous development and many new versions appear. So, kaya siya tinawag na FREC family kasi ang daming versions na lumabas since nung first model na nagawa noong 1968. And isa sa mga tatlo sa mga sikat na model ng FREC are FREC 10, FREC 10PE, and FREC 10PL. Ang main focus ng FREC is it is a major input offset of ramp counts based on origin destination information and priorities for freeway and arterial roads. So dito sa FREC, ang pinaka-focus niya is yung mga ramp metering and speed flow relationship for high occupancy vehicles facilities. So, dito sa FREC, kino-consider yung mga traffic light, kung saan dapat maglagay at kung gaano karami. Kasama na din ito yung mga road signages na makikita nyo. So, ang FREC, marirelate ko talaga siya sa US lang kasi siya ginagamit. So, kung i-relate ko siya dito sa Pilipinas, ang pinakamalapit na meron tayo is yung bus lane. So, sa lahat ng macroscopic models, sa FREC yung pinakamaluwag dumaan kasi nga limited lang yung may access dito. Pero, hindi rin pwede magpalipat-lipat ng lane. Kumbaga, limited lang din yung galaw ng mga sasakyan doon. So, overall, the output of FREC contains freeway for performance tables for travel time, speed, ramp delays, and queues, and fuel consumption or emission. The third one is Free Flow. It is a simulation model developed by Payne that was a successor to the Mach 2 model. This is limited only to simulating congested flow conditions and generates point detector information for calibration and validation. So, dito sa Free Flow, before this one, merong Mach model na tinatawag, which is just consists of a set of conservation equations and speed density equations for evaluation of ramp under congestion condition. So, under Mach, there are Mach 1 and Mach 2. And yung free flow, nag-originate siya sa Mach 2 model. So, yung free flow, ito yung pinaka-limited na model kasi ang main focus niya lang is traffic congestion. So, lahat ng data na makukuha sa kanya is about traffic jams. So, kung gaano kabagal yung daloy ng traffic ko, kung gaano karaming sasakyan yung na-stuck doon, and etc. To address its limitation, FreeCon was another model developed and incorporated into TRAF to interface with other model. So, dahil nga limited lang yung kayang gawin ng free flow or yung information na kaya niyang ibigay, nagkaroon ng bagong model or improved model niya, which is FreeCon. Then, nilink to sa TRAF para magamit sa ibang model so we could get many more information. So, these enhancements can now simulate a freeway with mixed modes or ramp metering and also provide some volume and routing information. So, since dinevelop siya ng ganon, then nilink pa sa another models, etong free flow na dating limited lang sa traffic congestion, ngayon, kaya niya na makapag-generate ng information about rerouting and kung gaano karami yung pwedeng dumaan sa new route na yon. So, for example na lang nitong free flow ay yung mga one-way roads na meron tayo to avoid going to the main highway para hindi na makadagdag dun sa mabagal na daloy ng trapiko. The third one is Kronos. Kronos is a freeway simulation model that uses a simple continuum model to represent traffic flow that is developed by Michalopoulos in the early 1980s. Kronos is a unique macroscopic model as it is the only program that considers the flow interruptions such as lane changing, merging, diverging, weaving, and spillback. So, comparing this sa mga naunang tatlong model, kung napapansin nyo, walang nag-discuss about sa flow interruptions. So, etong Kronos, yun yung main point niya. Dito tinitignan yung epekto ng lane changing, merging, diverging, at iba pang maaaring makaapekto sa daloy ng trapiko. This is used for traffic parameters, freeway and ramp characteristics demands, and origin destination information. So, overall, Kronos give us an output that contains both numerical and graphic representation of flow conditions and congestion level and estimated common measures of effectiveness. So, etong Kronos, pwede siyang magamit para maging basis to sa kung anong mga dapat ipagbawal sa kalsada para makaiwas sa pagbagal pa ng dalaw ng trapiko. So, etong Kronos, nagpapakita din to ng yung effectiveness ng current common measures so we could improve it for the better.
Now I'm going to discuss the mixed network. Mixed network is a method for simulating mixed freeway arterial models through a traffic assignment subroutine to simulate an integrated system. So most of the model in this category are able to model complex network in considerable detail. Consequently, a common disadvantage is the extensive requirement for input data and the calibration. Under this method, there are two categories, the microscopic and macroscopic. Now, I'm going to discuss about microscopic. The YAMSON. YAMSON stands for the Advanced Interactive Microscopic Simulator for Urban and Non-Urban Network. So, YAMSON is analytical part of JETRAM or Generic Environment for Traffic Analysis and Modeling. So, JETRAM can input processor traffic network to graphical editor. Then the data from TEDI can analyze that contains interface with assignment model. YAMSON is a microscopic simulator that deals with all types of street in integrated fashion. So, YAMSON can accommodate traffic movements in either turning or OD matrix. So, when turning movements are used, traffic is allocated random manner over the network. That's why YAMSON developers have made extensive effort to accommodate ITS features such as variable message sign, in-vehicle travel guidance, detector, actuated sign control, ramp metering, and element for incident management. Next is CoreSIM, a combination of NetSIM and PreSIM. NetSIM represents traffic on urban street while PreSIM represents traffic on highways. It's a microscopic traffic simulation software. It's packaged for signal system, highway system, freeway system, or combined signal highway. A traffic assignment model can be run to enter origin to destination trip information and two assignment options. System optimal or user equilibrium can be selected. The assignment result then interface the component of collision model. A Windows version of TSIS or Traffic Software Integrated System was released by Federal of Highways Administration in 1997 to allow the user to customize the setup including tools, define management's traffic simulation analysis, execute traffic simulation models, and interpret the result of those models. Next, integration. Integration was developed in late 1980s by Van Erd and Association, where individual vehicle movements are tracked through the network and to monitor and control the behavior of vehicle belongs to a specific subgroup. Integration also a routing base, where the origin, destination, and departure periods of vehicle trip are provided outside of the model. Integration may be the first model that considered that ITS route guidance. ITS stands for Intelligent Transport System. Its additional features include data gathering from a user-specified detector location and base signal optimization at user-specified interval.
Now that Mr. Artilio have already discussed the first three microscopic model for mixed networks, let's now continue to the three remaining software. First is Paramix. Paramix is a network-level microsimulator developed by Quadstone in the 1990s in the UK. It has one base, which is basically the core simulation component, the modeler, and three optional components, which are processor, analyzer, and programmer. It also requires Windows operating system. And based on what I have researched, the latest version is version 24, which was launched last September 2020. Since microscopic yung model approach ng Paramix, masasabi nating suitable siya sa pag-assess ng mga detailed effects. Like for example, yung mga temporary lane closures due to incidents or road construction. Also, yung mga iba't ibang speed limits for specific types of vehicles. I've included pictures here para ma-visualize mismo natin yung interface ng software. Basically, may set of tools that highlight vehicle choice, as you can see, the route choice, lane choice, and giveaway choice. And also, we can customize vehicle behavior with incidents, yung mga common occurrences sa kalsada, like vehicle breakdowns, accidents, yung mga hindi maiiwasan, and then yung mga drop-offs, pick-ups and deliveries, and even electric vehicle charging. So, dito pinakita ko lang yung screenshot nung mismong software. Then, other features include on-street and off-street parking. So, this feature is useful especially para sa pag-develop ng mga city parking strategies. Other feature also includes creating beautiful 3D visualizations. So, pwede kang mag-add ng textured road surfaces, pavements, sky, shadows, and etc. And you can also share the simulation by capturing it as a movie. Then next we have SCOT, or the Simulation of Corridor Traffic. So, this is among the earliest model for integrated networks. This model is a synthesis of UTCS1 and DAFT. Kumbaga, itong model na to ay pinaghalong UTCS1, which based on what I've researched is the precursor of NetSim, which has been discussed earlier, and DAFT, which is a mesoscopic simulation model for freeways and ramps. I've tried to search for examples ng interface ng software na to, pero sadly, dahil nga lumang model siya, wala akong nakita. So let's now move on to the next and last, the WATSIM or Wide Area Traffic Simulation. This is developed by KLD Associates. It is a stochastic integrated network simulation model that extends the functionality of TrafNetSim. So, di ba kapag sinabi nating stochastic, di ba parang yung outcome involves random probabilities and uncertainty. Basically, itong WATSIM software is parang in-improve yung functions na nagagawa ng TrafNetSim na na-discuss na kanina sa urban street networks. Ang difference lang is nadagdagan ng HOV configurations, light rail vehicles, toll plazas, path tracing, ramp metering, and real-time simulation and animation, as you can see on the figure on the left side.
Another classification of traffic engineering simulation softwares under mixed networks macroscopic is CoreFlow. CoreFlow is basically a combination of NetFlow 1, NetFlow 2, and FreeFlow models. However, the only difference is that CoreFlow is integrated within the TRAF or TSIS operation environment. And that's what my members discussed earlier. FreeFlow is used to simulate the traffic on the freeway subnetwork, while NetFlow is used for the surface streets network. So, therefore, CoreFlow is expected to cover all these networks covered by FreeFlow and NetFlow. Two important enhancements to CoreFlow are the addition of new logic for user-optimal traffic assignment based on simulated link travel time and the introduction of capacity for en route diversion modeling. Therefore, within the TRAF or TSIS system, the equilibrium traffic assignment model may be used to provide volume and routing information to FreeFlow and NetFlow. According to my research, CoreFlow is also suitable for the assessment of the operational impact of incidents, reconstruction, bottlenecks, design alternatives, and control strategies in highway networks composed of freeways and surface streets, which is usually tackled by the FreeFlow and NetFlow. CoreFlow is also suitable for many planning activities such as the assessment of network performance as a function of fluctuating origin-destination trips, regional control strategies, and traffic diversion strategies. Since CoreFlow is a combination of two simulation traffic engineering softwares, it is expected to perform better than these two.
Model selection, output variability, and other limitations. Model selection. Models have characteristics that may or may not fit a specific application because of their specific attributes, strengths, and weaknesses. Thus, selecting a model is an important step toward traffic problem resolution. So, kada model mayroong advantages at disadvantages, kaya mahalaga na malaman natin yung mga yun para makapili tayo ng model na matatapatan yung demand ng project or system na gagawin natin. So, meron ditong binigay na criteria para ma-evaluate yung mga models na binigay kanina. Una is quality of modeling in terms of traffic engineering theory. So, dito yung principles used for constructional details lang or simple yung mga design patterns. Pangalawa, quality of program code. Dito sa quality of program code, yung specific information na naka-store dun sa variable dapat easily and quickly accessible yun. So, otherwise, magkakaroon ng incompatible outputs tsaka absence of link from one software to the another software or planning software. Pangatlo, users friendliness and documentations. Yung una, users friendliness, concern siya sa users perspective. So, kung paano ba yun? Siyempre, dapat nakapaloob yun dun sa documentations. Yung documentations kasi, ito yung bagay na nagpapasimple sa paggamit ng isang software. Halimbawa, nag-install ka ng software, tapos Arabic yung language, siyempre, mahirap yung gamitin kasi iba yung language. So, sa engineering software naman, ang kadalasan na ginagamit nila is metric system or metrics, software metrics tsaka process metrics. So, mas nare-reduce na yung difficulties sa paggamit ng software na yun kasi common globally yung ginagamit nila. Pang-apat, field validation and verification. Yung mga model kasi nagre-represent sila ng theory ng software. So, dito papasok yung empirical data. Kaso, may nagiging problema kasi dapat yung model must be validated. Minsan kapag hindi validated, nagkakaroon ng problema. For example, nag-run ka ng program. Ang sasabihin lang ng program is hindi to magra-run kasi mali ka. Yun lang, pero hindi niya sinasabi na dagdagan mo ng tuldok yung row 3 kasi kulang ng tuldok. Parang ganun. So, hindi niya sasabihin yun. Bakit? Kasi walang data na to compare with. Kumbaga, hindi siya naka-store. Kaya, kailangan mo ng largest model. So, kapag maglalagay ka ng largest model, kailangan ng huge effort yun. Panlima is availability, implementation, cost, and support. Dito napapasok yung dapat yung model na pinili or pipiliin natin, dapat they do not confuse their models with the reality. Dapat makatotohanan yung ipoprovide niyang actual model. Kasi kasunod na nun is implementation, cost, tsaka yung support. Tapos dito sa output variability, masyadong technical yung terms na ginamit. Kaya yung definition is yung variability na lang kinuha ko. Yung output, alam naman natin lang yung synonyms ng result. So, variability referred to as dispersion or spread. So, ayun lang yung pagkakaiba-iba ng output or result. So, itong dalawa, independent replication tsaka batch means, sila lang yung frequent use method sa pag-test ng variability. So, ang pinagkaiba lang yan, yung independent replication is long stabilization, tapos yung batch means naman ay quicker or single run lang siya, single simulation. So dito wala namang masyadong ang kailangan lang is ito, the variability in model output can lead to concern about the model's reliability, and the user may have difficulties in analyzing the simulation results under different control strategies. To avoid confusion, dapat consistent yung output. Yun lang yung dito sa part na to. Other limitations. Broad limitations of traffic simulation includes, so alam naman natin na yung traffic simulation is software, so talagang merong limitations. So una is imperfect simulation of driver's behavior. So kung mapapansin nyo dito sa right side po sa picture, picture lang kasi yan pero yung totoong model niyan gumagalaw. So yung mga bus dyan, tuloy-tuloy lang yung pagtakbo, pero in reality, hindi naman ganun yung nangyayari. Kunwari sa EDSA, pag-ewang-gewang yung mga bus. Pangalawa, approximate representation of the reality. Ayun lang yan yung picture itself. Kung ano lang yung in-stock ng programmer na graphics niya, yun lang yung ipapakita niya. Excessive hardware demands. Dito sa excessive hardware demands, dito yung traffic simulation software, nagde-demand yan ng yung iba mataas na specs yung kailangan. So, pag pipili ka ng model, dapat mo rin consider yun. Last, inconsistent simulation reports. Hindi ito masyadong pansinin, pero sa mga traffic software and simulations, meron yung mga bugs na may encounter kapag ginamit natin.